Hello and welcome to the brewery. It's been a while, but we're back again, this time with a different project. Now, some of you may know what this is. If I turn it over, that'll make it more obvious to some of the rest of you. So that is a PLAATO Keg. What they are is some scales that were on a Kickstarter many years back now, to tell you how much beer is left in your keg. They go off to a cloud service that you can then get data out of and report and integrate into lots of stuff. They're really good, but unfortunately the company that makes them is shutting down the cloud service that they depend upon, so they're obviously all going to stop working. Now, this is a bit annoying. I've been using them for years to keep track of how much beer is left in the kegs in the kegerator behind me. There we go. So now I need to work out how to make them work again. There are a number of projects going on to try and keep these kegs working, but I decided to go for a more complete approach that would allow people to build new devices from scratch. In this video, I'll talk a bit about the process behind designing and building the devices, and I'll follow up with some more videos on how to make the hardware, how the app works, and how to make your own enclosure from scratch. This whole project comes with a warning that this isn't a simple plug and play fix. It requires some work to get it going and is very definitely still at an early stage of development. So, to start with, let's kick off with the keg device itself. I've opened one of these up in the past a couple of times before, initially to fix an electrical problem, so I'm fairly familiar with what's inside. We have 3 load cells and a load of custom electronics from the original manufacturer. My first decision in this project was that I was going to scrap pretty much all of the existing electronics. I'd keep the load cells, and initially I planned to keep the charging port, but I got rid of that eventually as well. I decided that it would be much easier to work with a well understood microcontroller that I was familiar with, rather than trying to work out exactly what all this custom electronics was doing. So I decided to use the Raspberry Pi Pico W, as that's what I used in my tap handles project, linked somewhere above, as they're easy to use and well documented, lots of stuff you can find out about them online, and they're very easy to interface with other hardware. The first thing I had to deal with was how to integrate the load cells, the things that actually measure the weight of the keg, with the Raspberry Pi. In my previous hacky keg scales project, I'd used 4 cheap load cells, which is similar to what you find in a set of bathroom scales. But the keg device here uses 3, which is interesting, but does mean it balances like a 3-legged stool and therefore can't wobble. As a quick technical aside, when I used 4 simple load cells in the previous project, I wired them into what's called a Wheatstone bridge to get the average measurement. The fact that the keg uses 3 cells instead of 4 means that this isn't possible, but it implies that each of the cells already contains their own bridge, and therefore I can just wire them all up in parallel. It does mean that for the scratch-built version of this project it'll be a little harder to source the load cells, but I have found where we can get them from. So, to connect the load cells to the Raspberry Pi, we need another bit of electronics. This is called an HX711. There are a few of these, and I would advise people to buy the purple ones linked below. I think there's some red ones that are equally good, rather than the green ones you'll see me using in a fair amount of this video, as the purple ones appear to be a lot more stable and give much more accurate measurements. Anyway, I wired the load cell into the HX711, and then the HX711 into the Raspberry Pi, and the Raspberry Pi into the power supply. I will talk more about this in a later video. This is where I made a mistake that took a long time to work out. These 2 wires here should be the other way round. This setup works perfectly when the Raspberry Pi is still plugged into a USB cable, so I can see which allows me to see what's going on. But as soon as I tried to make it work off the external existing power supply, the load cells stopped working and were just giving 0 readings constantly. For the geeky among you, this is the difference between the VSys and the VBus connections on the Raspberry Pi, and exactly how they work with the rest of the Raspberry Pi power circuitry. When I had them backwards, when I was powering through the external power supply, the HX711 was just not getting powered. Once I'd solved this and rewired all the ones I'd tried to build so far, they worked perfectly, and it was time to move on to the software. So, Given the problems with the central server for the project that was just being shut down from the original commercial project, I decided that my version should be capable of running without any dependency on a central service or system that someone would have to run. In order to do this, I decided to run the entire system based on Bluetooth, more accurately Bluetooth Low Energy, as its primarily means of communication. The system can access the internet, but this is currently only to allow for over-the-air updates and for remote debugging in case anything is wrong. The system itself has two main components. The first part runs on the device itself. This takes measurements from the load cells, smooths the value out a bit, converts them into volume measurements and makes them available to read over a Bluetooth connection. It also detects when the beer is being poured from the keg and alerts any connected devices when this is happening. Technically, this is a MicroPython application that I'll talk a bit more about in a future video. Hopefully I've made it fairly easy to install and it should update automatically when you reboot it. Connected to this is an Android app. Sorry, I haven't done an iPhone application yet. I don't understand Android applications much better than I do iPhone ones, so that will come in the future. This app displays the data from the keg and allows you to configure the devices. Once you've scanned for and detected the devices, you can do things like give them names, set the volumes, connect them to the Wi-Fi and calibrate them using empty and full kegs to show them what an empty and full keg weighs. Well, the project now is at a good stage, and as you can see behind me, I have two kegs with the new system in the kegerator measuring well. There's still a little bit of work to do to make it easier to install and easier to run, but instructions on that will be in the next couple of videos. I hope you enjoyed that and are interested in the project, and I will see you in the next video.